Descartes' rule of sign. Let P be a polynomial with real coefficient. The number of positive real zero of P of x either equal to the number of variation in sign of P of x or is less than that by an even whole number. The number of negative zero of P of x either equal to the number of variation in sign in P of negative x or is less than that by an even number. So Descartes' rule counter multiplicity. So for example, P of x equals x squared minus 4x plus 4. You can factor that. It equals to x minus 2 squared. It has 0 at x minus 2 with multiplicity of 2. So according to the Descartes rule, P of x change sign twice. So there is 2 real zeros. So look, it changed from positive to negative to positive. So it changed sign twice. So therefore, there is 2 real zero. P of x is quadratic. So it also have at most 2 zero, right? Because it is x to the second. So that's the number of zero that we got. Now use the Descartes rule of sign to determine how many positive and how many negative real zero that the polynomial can have. Determine the possible total number of real zero. So let's check the number, the sign that is changed for P of x. So start with positive, then it's going to negative, then it's still negative, and it's still negative. So P of x change sign one time. This means it's telling us that we have either equal to the number of variation in sign of P of x is less than that by an even whole number. Well, an even whole number here is 2. Here in this case, if the change sign only 1, this then implies that we have one possible of real zero. A positive real zero. Okay, so let's take a look at P of negative x. Well, P of negative x equals negative x to the third minus negative x squared minus negative x minus 3. This becomes negative x to the third minus x squared plus x minus 3. So let's see how many change of sign. So negative to negative, negative to positive, 1, 2. So change sign twice. P of negative x change sign twice. So then we have 2 possible of negative 0. Okay. Or is less than that by an even whole number. So this means we can 2 possible of negative real 0 or 0 possible of negative real 0. Let's take a look at the next one. So P of x start with positive to negative. So we change sign 1. So one possible positive real 0. And let's take a look at P negative x. That is 2 times negative x to the 6th plus 5 times negative x to the 4th minus negative x to the 3rd minus 5 times negative x minus 1. This becomes 2x to the 6th plus 5x to the 4th plus x to the 3rd plus 5x minus 1. So here there's only change sign one time. So then one possible negative real 0. Okay, so if you remember in the previous lecture, we have a list of the possible real 0 number, and sometimes that list can get pretty big, and to check every single one of them is time consuming. But here we have a way of checking whether we should continue going or whether we should stop and go the opposite direction. We have the upper and lower bound theorem. If p of x is a polynomial with real coefficient, if we divide p of x by x minus b with b greater than 0 using synthetic division, and if the row that contain the quotient and remainder have no negative entry, then b is an upper bound of the real 0 p. So if we start with b, and then we have O positive in the bottom, would mean we shouldn't go any higher in that list of the possible 0 that we have. We should go lower, right? If we divide p of x by x minus a with a greater than 0 using synthetic division, and if the row that contain the quotient and remainder have entry that alternative, non-positive and non-negative, then a is the lower bound for the real 0 to p. Alternatively, non-positive and non-negative mean that the side of the number alternate, with 0 considered to be positive or negative as required. Show that the given value for a and b are lower and upper bound for the real 0 of the polynomial. Okay. So a equal to negative 1 here. So negative 1, and let's do the synthetic division. 2, negative 6, 1, negative 2, 3. We bring down to 2. So note that here we have an alternated sign, going from positive to negative, from positive to negative, and back to positive, negative, and positive. So since we have an alternating sign, a is the upper bound. A is the upper bound. Of p of x. Let's take a look at b. So here 3, 2, negative 6, 1, negative 2, and 3. So note that here we have O positive. Okay, so synthetic division, if the row that contain the quotient remainder have no negative entry. Okay, so here we have no negative entry. This means b is the I switched your upper bound and lower bound. So a is the lower bound and b is the upper bound. So let's take a look at this problem. We want to find all rational zeroed polynomial, then find the irrational 0 if there's any. When appropriate, use the rational 0 theorem, the upper and lower bound theorem, Descartes rule of psi, and other factoring techniques. So we'll use everything that we ever known how to factor this. Okay. So let's start with the Descartes rule of psi. So p of x change psi 1, 2, 3, 4 times. So p of x change psi 4 times. So here we have 4, 2, or 0 possible real 0, possible positive real 0. Let's take a look at p of negative x. P of negative x is equal to negative ax to the 5th plus 22x to the 3rd plus 57x squared plus 35x plus 6. And it change sign one time. So we have one possible negative real zero. Okay. So leave that there for a moment. Now let's take a look at the list of the possible zero. Start with the factor of a naught. A naught equals 6. So p equals 6. So then we have the possible factor is plus minus 1, plus minus 2. Excuse me. So p is equal to plus minus 1, plus minus 2, plus minus 3, plus minus 6. An is equal 8. So q equal to plus minus 1, plus minus 2, plus minus 4, and plus minus 8. So the list of possible zero these are plus minus 1, plus minus 2, plus minus 3, plus minus 6, plus minus 1 over 2, plus minus 1 over 4, plus minus 1 over 8, plus minus 2 over 1, 2 over 2, 2 over 4, that is half, 2 over 8, that's the 4, that's already accounted for, 3 over 2, plus minus 3 over 4, plus minus 3 over 8. The next one is 6. 6 over 1, that's 6. 6 over 2, that's 3. 6 over 4, that's 3 over 2. 6 over 8, that's 3 over 4. And that is already accounted for. Alright, so we got our list of possible zero. So let's start with our syntactic division. Start with 1. So let's start with 1. So 1, 8, negative 14, negative 22, 57, negative 35, and 6. We got, so C equal 1. Okay. This meant that x minus 1 is a factor of p of x. Okay. So then I can write p of x equal to x minus 1 times ax to the 4th minus 6x to the 3rd minus 28x squared plus 29x minus 6. The next one that we try is x equal negative 1. Okay, and we will try this on the smaller polynomial. 8, negative 6, negative 28, 29, negative 6, and we get, so negative 1 don't work in this case. We'll try negative 2 next. We try 2 first and then negative 2. Let's start with 2. And again, we try it on the smaller polynomial. And we get, so 2 don't work, so let's try negative 2. And we get, so this means c equal to negative 2 and x plus 2 is a factor of p of x. Note that here we also have an alternated inside. This means c equal negative 2 is the lower bound of p of x. So we don't need to check for the negative 3 and so forth and so on and to negative 6. So that eliminate this many number that we need to check. Okay, back to our problem. I can write p of x now as x minus 1 times x plus 2 times ax to the third minus 22x squared plus 16x minus 3. Okay, so now since I don't have to check for the plus or minus 3, plus or minus 6, let's go ahead and check for the rest of the number. And I'll go, since I've already done this before, what next I'll check is 3/4. Okay, so let's check for 3/4. And again, we will perform this on the smaller polynomial. So 3/4 on 8 minus 22, 16, negative 3. And we get, this is what we got. So this meant c equal to 3/4 is a 0 to p of x. This meant x minus 3/4 is a factor of p of x. So then I can rewrite p of x as x minus 1 times x plus 2 times x minus 3/4 times ax squared minus 16x plus 4. So now that I have a quadratic here, I can factor that using the quadratic formulas. Okay. So let's go ahead and factor out 4 to begin with. So factor out 4. So x minus 1 times x plus 2 times x minus 3/4. That leaves us with 2x squared minus 4x plus 1. And note that this factor, this polynomial here is not factorable. That quadratic is not factorable. So let's go back to see what exactly does our question want. Do we want to stop here or do we want to go further? So we're asked to find all rational 0 or irrational 0. Okay, so to find 0, we need to let p of x equal to 0. This means we already have x equal 1, x equal negative 2, x equal to 3/4 by doing the synthetic division earlier. Now we can solve for this polynomial, this quadratic equal to 0 by using the quadratic formula that negative b plus minus square root of b squared minus 4ac divided by 2a. So negative b is 4 plus or minus square root of 16 minus 4 times 2 times 1 divided by 2 times 2. That is 4 plus or minus square root of 16 minus 8 divide 4. That is 4 plus minus square root 12 divided by 4. So 12 is 2 root 3. So that is 4 plus minus 2 root 3. divided by 4, and that is 2 plus minus root 3 divided by 2. So these are the zero of the polynomial.